Hello, look. Our goal was to introduce something which is called Alpha Earth Embeddings. It's actually embeddings trained on many different data sources, like multi-domain data sources, and those embeddings they consider them as pictures, right? But they are much more than pictures. They're much more than satellite data. They're much more than LiDAR data, right? So these are data sources used to create these embeddings, right? And maybe this one is very interesting because they use actually Wikipedia text. Wikipedia text is somehow encoded in those images, right? And you see also LiDAR data, you see climate data, you see elevation, land cover, gravity fields, you know, very interesting, right? And we already used those embeddings to improve weather resolution models, right? So we can go from this much here, using our embeddings, to very precise temperature map of an area. This is a very powerful tool, and we were thinking how can we leverage it to use in Rural Plus. And I will be jumping back and forth because I just made this presentation and I don't know the order of the slides. So we decided to use it to search for geospatial twins. What does it mean? It means that, imagine, you are interested in particular region, and maybe your region can do much better than it does now, or maybe the opposite. And we want to search for geospatial twins, means region of an arbitrary size that has similar geospatial properties. And these geospatial properties, since they are created by those huge data sets, they include a lot of information. Yeah, so these are like embeddings from latent space. We don't really understand them as humans, but they can be a very powerful tool that has to be, of course, verified in practice. And imagine you found, let's say, a sister region, and you see that the sister region is doing much better. How do you know that it's doing much better? Because we have Jackdaw for this. Jackdaw has a lot of tools that can analyze and explain to you like what are the point of interest, characteristic potential, and so on and so forth. So if we find a sister region which is doing much better than others, we can say, okay, so maybe we can change some things in our region so our region can do better. Go back. This is just a fancy image I downloaded from the internet. So this is basically the way how the embeddings are done. Several domains, and then we get a tensor, right, which is in this case just can be visualized as an image, but this image is way more than just a visual image. And the core idea, as I mentioned, is first we identify geospatial twins. We use this Alpha Earth embeddings to find regions with matching physical footprints, infrastructure, and land use. Then we leverage Jackdaw to uncover socio-economic drivers and policy insights that raw satellite data misses. Then we compare development, and we look at the success stories between similar regions to pinpoint specific growth gaps and opportunities. And then we can again use Jackdaw to synthesize proven strategies from global sister region into localized actionable development plans. And then we convert all the complex geospatial data embeddings into clear, high-impact narrative for stakeholders and investors. And there's just example how this similarity search works, right? So in this case, it's not very like clearly visible, but we like click here and you see these light pixels that are identifying the region we clicked on, and those red points, which is 1, 2, 3, 4, 5, these are the sister regions. And we are not limited by like the size of the region, but in this case we can identify like bigger regions. In this case we clicked here, which was like just some homogeneous smudge on the map, just to show you how it looks like. And we've already implemented it to our sandbox chatbot, and this is an example how it looks like. So yeah, we clicked on some point and we identified 4 similar points, which we can again use in Jackdaw to describe, plan, and get information. So thank you for attention.
Thanks, Alex.